All right, kiddos, question 16. We got a colony of bacteria grown under ideal conditions in a lab so that the population increases exponentially with time. At the end of 2 hours, there are 5,400 bacteria. At the end of 4 hours, there are 48,600 bacteria. How many bacteria were present initially? So what you can do with this is just kind of think about what's going on. We're gonna go along something with. Let me get some ink going here. That's a nasty looking guy. Y equals some amount times some base to some exponent is basically what we're looking at. And, that could very easily look like this. A of t equals A times the initial amount times e to the rt, or some form of this. This is an exponential function. This is exponential. But I don't think we're going to have a base e here. And here's why I say that. If we start with an initial amount of 5,400 and we stop with an amount of 48,600, we can actually do a little bit of math to see what happens. Remember, this is growing over a 2-hour period from 2 to 4. So if I take that 48,600 and I divide it by 5,400, check it out. I'm going to get I'll just punch it in real quick. I'm going to get 9. All right. So if you'll think about this, what's happening is we're getting some number. We're multiplying it again. We're getting another number. We're going to multiply it again to get another number. Well, it took us 2 hours to do this part right here. And this also is more pre-calculus-y than calculus-y, but it took us 2 hours to go from 54 to 48. So if you think about what times what is 9, because remember, when you talk about exponential growth, you're talking about taking a same base, multiplying it time after time after time. And what happens is if you look at 9, 9 actually is the same thing as 3 times 3. Well, that's where our 9 comes from. It comes from 3 being squared, okay? And so if I know that my base part is 3, I can now go back and solve for my initial amount, all right? So now what I'm going to do is I'm going to let A equal, or I don't know what A is. That's what I'm trying to find. But I know that this B value is going to be 3. Again, think about it. With exponential growth, you have a base times a base times a base times an initial amount. And in here, if I have 3 times 3 over those 2 hours, I get this number, all right? So if my base is 3 and I know a specific amount of time after 2 hours, so what I can say is A is equal to, let's do this actually. Let's take my 2-hour time population, 54,000, equals my initial amount, I don't know, times 3, and then the number of hours it took to get to 54,000. It says right here 2. So I can work this out. Well, that's going to be 54,000. 5,400 equals 9A, and when I divide that by 9, I get 600. So that right there is my initial amount. And again, just like on question 15, these two guys aren't necessarily calculus-y questions, but they require us to have a really good understanding of how exponential growth will work. All right, so if you don't quite see how this one works right off the bat, and it's a little bit different, try solving it again on your own and see if you can get the same number, and then come back and watch and see if you need a hint. Okay?